because Earth is spinning, right? So we just did this non-spinning Earth model, so you kind of see what's going on there. But the fact that Earth is spinning, there's something called the Coriolis effect, right? And think about if you were living in Quito, Ecuador, right? So Earth has a much larger diameter or circumference at the equator than it does up here at the latitude of Buffalo. And so in other words, at the latitude of Buffalo, remember Earth rotates, for every hour Earth spins, it rotates 15 degrees of arc. So 15 degrees of arc in 1 hour, Quito has moved 1,668 kilometers, or basically 1,000 miles. So in other words, Quito is moving at about 1,000 miles per hour as Earth spins. But in Buffalo, New York, in that same hour, it only moved 783 miles, right? So it's traveling 783 miles per hour. So in other words, it's the spin or the movement is slower as you go to higher latitudes or lower latitudes, right? Farther from the equator. And so that's the Coriolis force. So what will happen is objects will be deflected from their original path, right? So that's kind of the same thing there about Quito, and this is just looking for the North Pole down, right? So that 1 degree of arc, right? 1 hour, 15 degrees of arc. And then, so what would happen if any object that starts off at a faster velocity, as it moves north, it's going to get ahead of or move to the right of the Earth's surface because it started off as a faster velocity, but Earth is moving slower up here. Right? Remember, this is for the air. Same thing if you start off at a slower velocity, and as you move south, you deflect toward the right again because Earth is moving faster closer to the equator, right? So there's this deflection. And the key to this deflection for this Coriolis force is that in the northern hemisphere, I put NH for northern hemisphere, there's a deflection to the right. Whereas the southern hemisphere, that deflection is to the left, right? Sometimes we say clockwise in the northern hemisphere, right, toward the right, and counterclockwise for the southern hemisphere, to the left, right, counterclockwise. That's another way we say it there. So saying that, now we'll have a spinning Earth up here, right? And so in the northern hemisphere, objects will be deflected toward the right. So up in this ferrule cell, you'll see that. Now I'm going to draw solid arrows. That the surface wind is going to be moved toward the right. So these are our surface winds. Surface winds, right? So we're looking at these surface winds right here. So they're going to be deflected toward the right. And then, so same thing here. For the Hadley cell, they're going to be deflected toward the right. So I'm just kind of showing it that's toward the right here, right? And then for the polar cell, same thing, toward this one, since it's moving back down, they're going to be deflected toward the right here. So actually, we got to look at it this way, right? Toward the right, because the arrow is going, so it goes toward the right. So it's a direction. In the southern hemisphere, it's toward the left. So here, for the Hadley cell, we make this go towards the left here, towards the left there. And then obviously you got to flip this around, but you'll see that this is left in the ferrule cell over here. And then it'll be left, that's the, let's make sure we get this right. So left is, no, that's right, that's left. See, it's a little confusing. This is my left side, that's my right side, right? Left, right. Okay, so that makes sense. So anyway, to get these wind belts, some are blowing this way, some are blowing in the other direction, this way or that way, right? And they have special names, and you've probably heard of these names. So the winds that occur in the Hadley cell are called the trade winds. The trade winds. You've heard of these trade winds, and so they're blowing from east to west. The ones in the ferrocell are called the westerlies. Westerlies. And then these would be the polar easterlies. Polar easterlies. So that's kind of the whole, just kind of figuring out how atmosphere, where the origin of these trade winds are and westerlies are. So the other thing I want to add here is that there's these boundaries, tropical or meteorological boundaries, and we'll talk more about them when we do the atmosphere. But this one's called the ITCZ, which stands for the Intertropical Convergent Zone. Intertropical Convergent Zone. And then the westerlies are called, the boundary between the trade winds and the west are called the horse latitudes. I'll put HL for horse latitudes. And then the polar fronts, polar front. And again, we're going to talk more about atmospheric circulation later on in the semester. But now I just wanted you to understand what the trade winds were and the westerlies, because these are going to start pushing on the ocean and start making the surface currents. And so that's what we want to get to next. So let's stop here for now.